This is an important fact that already demonstrates the relations of these building blocks throughout the whole concentric hierarchy. The relation is consistent, regulars over irregulars, and using same size spheres. This also demonstrates that there is no cube or square root of 2 edge that can be modeled via blocks because of its existing irrationality in higher exponents. Fermat's theorem also started with Pythagoras. So all in all, synergetics uses a h2 cube as if square root of 2. This is the cube he uses as if it would be this cube. But let's confirm. Let me divide the volume 8 cube, this one, to synergetic 72 blocks. So let's just see what happens. And be sure we have the same cube. So 8 divided by 72 equals 0.111111111 times 9 equals 1. So here is the missing 9 modular cube. Here is the synergetics unit volume regular tetrahedron. That has 24 blocks. So 24 times 0.1111111 equals 2.666666667. Again, the numbers confirm that this 2.6666667 is 1/3 of this volume 8 cube. So the relation is same. We have the same cube. The synergetics must be wrong. Now, at 2.828427125 times 1.060660172, which is a synergetics constant, equals 3. So this constant converts an irrational volume cube to a rational volume. Hey, I invented a z constant, volume 8 cube times 0.375, that's my constant, what a stupidity, equals also 3. So we achieve the same effect. So let's use a reverse function to both, just to balance our equations. So 2.828427125 divided by z constant, I am even embarrassed to say that, what the idiocy. Well, anyway, divide this cube by 0.375 equals 7.5424723331. So a volume 8 cube divided by now synergetics constant 1.060660172 equals also 7.5424723331. We came up with same answers. Same is true in any magnitude. So let's say 2.666666667. This is a that volume in this volume 8 cube times 6 equals 16. So that equals 2 cube, same as a rhombic dodecahedral volume. We again just confirm behind any reasonable doubt that synergetics is actually very incorrect to forcing a volume 8 cube to be of 2.828427125 cube. It is also very puzzling why these facts are not known to any synergy enthusiasts. Why they always act so confused. Well, perhaps the accent. So the synergetics constant establish these two different cubes, this cube and this cube. So we see the relations. So we know that Pythagoras squares imagined as cubes is a very accurate way to describe what the synergetics constant actually is and how it operates in these actual cubes, and also demonstrating that it is completely meaningless because in reality we both using the H2 cube volume 8. A synergetic two-frequency cube volume must be 22.627417. That's this cube. 2 times square root of 2, diagonal 4. Well, let's divide this cube, let's multiply this cube by synergetics constant. Let's see what's happened. So 22.627417 times the synergetics constant equals volume 24. That's the edge 2 times square root of 2, that's this one. Where in fact, the edge 2 cube, this one, is volume 24. Here is the proof. We have couplers, we both have couplers in synergetics because we both have mites. So this is the synergetics mite, and when you flip it around, Kirby confusingly calls this a duotet cube because he says we can visualize the tetrahedron edges in here. Well, visualizing is something different than actually modeling. But in my case, with my superior blocks, yeah, we can model. With synergetics, you only maybe can imagine, you cannot model. But anyway, so we see that this cube is volume 24 because there is 6 of these half oblate octahedrons in a cube, that's this cube, edge is 2, excuse me, and that's the same cube synergetics has. And a coupler is a volume of 1/3 of a cube. That's in both cases, no big deal. But we see that there is 6 of these halves in a cube. So, and there is 1, 2, 3, 4. So 6 times 4 is 24. So this cube volume is 24 regular tetrahedral volumes. That's like this. This is the unit volume, if that's what synergetics want to do. And so there is 24 volumes of this H2 cube. Now here we have another coupler where we see that this coupler, it's the same coupler, same oblate octahedron, just modeled different ways. And we see that this one has the inner octahedron in it. This octahedron is half the regular tetrahedral volume, which is inside of it. And it also has 24 tetrahedral volumes. This one does. Same like that. But this cube I usually refer to as a 48 tetrahedral volumes because 48, these are half the size of the unit volume tetrahedrons. So the lowest common denominator using the smallest block is 48. Thank you.